So we'll continue our triangle review now with some algebraic triangle problems here. So first I have an exterior angle here. And an exterior angle is always equal in measure to the sum of the two remote interior angles. So 5x, the exterior angle, is equal to the sum of these remote or far away interiors. So it equals 30 plus 45. Okay, 30 plus 45, that's 75. So 5x equals 75. Okay, so I can use this. I can check what I just did. 30 plus 45 is 75. And then divide by 5. I get 15. So x is 15. Okay, now on this equilateral triangle, I've got a couple of options. I could do that same thing because I know that an equilateral triangle is 60, 60, 60. If we don't know that, then we know that the triangle's three angles have to be the same because it's equilateral. So a triangle is always 180 divided by 3 is 60. So I've got 60, 60, 60, that's the case for every equilateral triangle. So I could do just like this. I could do 2x plus 10 equals 60 plus 60, or I could use this linear pair here and say they add up to 180. Let's do that. Since we've already done this way, let's do this method here with the linear pair. 2x plus 10 plus 60, there's my linear pair, and a linear pair always adds up to 180. So I've got 2x plus 70 is 180, and I'll subtract 70. So 2x equals 110, and divide by 2, and 110 divided by 2 is 55. Okay, a triangle always adds up to 180, so x plus 4 plus 4x plus 86 is 180. Okay, so the three angles of the triangle add up to 180. Okay, so I've got some like terms here. X and 4x makes 5x. 4 and 86 makes 90. And I can subtract 90. And 180 minus 90 is 90, so 5x equals 90. And then 90 divided by 5 is 18, so x is 18. Okay, here is another equilateral triangle, just like this one up here. An equilateral triangle is always 60, 60, 60. So I know 6x is equal to 60. And I can divide by 6. 60 divided by 6 is 10. Okay, so here I've got four triangles kind of all put together here, and in this triangle right here, I have a 90 and a 15. And if I take those two away from 180, so I've got 180 minus 90 minus 15, that gives me 75. So this is 75 degrees. Now this top triangle here, when I put these top two together, I get one big isosceles triangle. And in an isosceles triangle, the base angles are congruent. So x is 75. Okay, now down here, I've got another little right triangle. There's a right angle right here. And I can take away the 90 and the 25 from 180. 180 minus 90 minus 25. And that is 65. So that tells me right here is a 65 degree angle. So y is 65. Okay, now this bottom triangle is another isosceles triangle, and its base angles are congruent, and since this one is 25, so is this one. So z is 25. Here, I've got a pair of congruent angles, and anytime a triangle has congruent angles, the sides across from them are congruent. So that tells me 6x equals 3x plus 12. So I'll subtract 3x and get 3x equals 12, and divide by 3, and 12 divided by 3 is 4. Okay, and then our last triangle in this set up here, I've got an isosceles triangle here. Okay, so that tells me this is 68 degrees because these are congruent base angles. Now this says I've got 90 degrees right here. Okay, so if this is 90 degrees and this is 68 of it, I can do 90 minus 68. And that's 22. So this is 22 degrees. Okay, now I need to find this one up here. So in this isosceles triangle, I can subtract the two 68s from 180. So 180 minus 68 minus 68. So 180 minus 2 68s is 44. So this right here is 44 degrees. Combined, these two angles right here make 90. So if I do 90 minus 44, I get 46. So this is 46 degrees. And now I can focus on this triangle up here. 180 degrees total. So I take the 180 total and subtract 22 and 46. And that is 112 degrees. So that's right here, 112 degrees. So x equals 112.